Tilburg University and MindLabs present TAISIG Talks, the podcast that keeps you updated on the latest developments in the field of artificial intelligence in just 1 hour.
Hello, welcome to the 30th edition of the TAISIG Talks. TAISIG is the Tilburg Artificial Intelligence Special Interest Group of Tilburg University. I'm Pieter Spronck, Professor of Computer Science, and in this series of talks we try to focus on research that is done in the realm of AI or related to AI at Tilburg University. And today's topic is data, which is, of course, underlying pretty much everything that is current day AI. And for this topic, I have invited a researcher from TAISIG. Ekaterini, can you please introduce yourself?
Yeah, thank you for the invite. It was really kind of you. My name is Ekaterini Ioannou, and I'm with TAISIG. And I've been here with Tilburg University for the last 6 years. And during my PhD and, of course, the research I did afterwards, I worked a lot on data. And the data coming from different systems, data collected from the web, and also how we can retrieve information from the data, how we can query it, and what does it mean that we have these data collections in the algorithms that we use today and in the tools that we have, and so on.
Yes, I understand that. So now I know that you work with data, but we discussed this a little bit before, and you were basically talking about the whole history of data, how it was used, let's say, 30 years ago, and how it is used now, and how we that come from one place to the other. And it might be a nice way to start discussing this topic.
Very good. Okay, so the thing is that data is not something new. We have been dealing with the data for the last 30 and 40 years ago. The difference is that the way that we use it and the challenges that we see are all the time evolving. So if we take it 30 years ago, we see that the data were only used by by very few players. For example, you had the data in hospitals, you had data used in banks, or you had data used in the governments. And there it was basically isolated, and you needed specialists to get the information out. And that was done by specialists that knew how to write SQL statements, and they were able to get what we needed out. And
you're talking now about data stored in actually structured databases.
Exactly, yeah. Exactly. Structured databases, controlled way. Some expert will make sure that all the information was correct, complete, and it was the way that we expect it to be, right? And what happened at some point, like 25 years ago, we had this evolution of systems. Like in 1998, we had Google. And then we suddenly started having even more systems, like we had Wikipedia, we had LinkedIn, we had Gmail, and then we had all the social systems. Like in 2004, we had Facebook, and 2005, we saw YouTube coming out, right? And that we had, and at that point, we had this explosion of data, and we had different types of data. So we were talking about unstructured data. We were talking about images, about videos, about sounds, and all these different ways to express your information. And actually, at that point, data was not just by experts, right? So it was everyday people that could contribute, that could expand this collective knowledge that we had. And you have all the information that is available online, and it's shared between the tools, and it's shared between the people, and it's propagated among all the applications that were available, right?
Okay, so data propagates, but now we are at a point, let's say 20 years ago, 15 years ago, maybe 10 years ago, but I think the big change there, well, there are several big changes. One is that data has a lot of different forms now. So there was a time it was basically, when it was structured, it was strings and numbers, and that is what you did your reasoning for. That's what SQL can work with, and then it became longer text, maybe unstructured text with mistakes in it, images, videos, sound. Could be lots of different things. So now we are about 10 years ago, probably, where this really took off.
Actually, the goal remains the same, right? So we have the users that want to retrieve information from the data. And what changed now is that we have different data challenges that we need to deal with. For example, we have a huge volume, and we are uncertain of the quality of the data, right? So we have slowly the tools, the available tools also introduce different analytics or different type of queries that users can use to retrieve their information. So we went, for example, from just retrieving information for why something, what happened in our data, right, into asking to retrieve information, why do we see the change? And more recently, like in the last 5 years, we can also ask what will happen next, right? What do the systems foresee that we will see in the next months or so? And the most late trend is asking the systems to tell us what we should do next. What they should use the information they have to determine what our next steps should be.
But are you now saying we didn't do that in the past? Because I think we did. Using data to make predictions, for instance, let's say sales data.
Yes, but exactly. And now the next step is telling us what we should do in our planning to see a specific prediction coming up in the future.
Yeah, but now you're talking about building a model. Am I correct? Because you use the data to build a model, and the model basically tells us what is going to happen or what will happen under certain circumstances.
Yes, and the next step is asking how we should change our variables, should we change in order for the model to go in one direction that we would like to do.
Okay, but do you say this is fairly recent?
Not fairly recent. No, this is the evolution on how it went. So this is how
we do more and more with
yes,
data.
Exactly. Yes. So we also ask more and more from our systems, right?
Okay.
And the prediction is that we will also in the future ask even more from the systems that we have, because they have more availability on the data, and also they have more availability in the technical processing that they can do.
Right. And of course, if you want to do this well, then you need a lot of data, which wasn't available in the past. On the other hand, since data has changed so much, also the quality, because you mentioned quality already, and I know you work a lot on that. The quality of the data becomes really important, because if you have low quality data, well, maybe if you have a whole lot of it, then you can still do things. But talk about quality.
So of course, data quality comes into play here. And when we talk about data quality, it's not just one aspect. It touches many aspects. And maybe I just give you some examples so we can see it in action.
Yeah, that is
so when the digital tools and the online platforms allowed our users to include geographic coordinates, right, in their images, so some users actually did. They made the effort to find exactly the latitude and longitude of where they shot their video or images and included it. And some users didn't. And when they didn't, the system recorded latitude 0 and longitude also 0. But this seems logical for our computers and for our data, but this is actually a geographic coordinate. It's somewhere in the sea near Africa, right? And what happened is that this error, this inconsistency, caused the creation of a virtual island, right? Where it didn't really exist, but if you queried it, you could find millions of photos, and you could find photos of an island that didn't really exist, but it had really nice mountains and beaches, and people Googled it, and people tried to book up vacations for it, but the island didn't really exist. Okay, and this is one example of what can go wrong in our data. What does it mean? It influences actually what comes out in the end.
Yeah, that's a very nice example, but of course one that would be easy to recognize. You can basically fix that with one condition, and
yes, but it took them a while, and by the time that they actually fixed it, it was already a problem. It existed in the data, right? And maybe another example is from the Enron Corporation. So they were investigated for an account fraud, and during this investigation, a large part of their internal emails were released. Okay, you will say, why is this a problem? The problem was that they actually released everything. The names of the real people, the events, the offices, their personal information. Also, there were emails with improper communication and so on. So it ended up showing that all these privacy issues, right, because they released everything, they had a long-term impact on the actual humans. So the humans were no longer employed by the company, but they moved on to different companies, right? And it actually affected their jobs and their families, and it had an impact that spanned for years for them, right? So we cannot just play around with data. We need to do it in a responsible way. We need to be respectful.
Do you also fit that under quality? Because then we have now already two kinds of quality.
It is an issue that has to do also with quality, I would say. So because you have this data that are public and the data that you are using, you also need to make sure that you respect also the privacy that you have, right? And this is really important when we have data from sensitive organizations such as health data, right? We would like also as researchers to use data from hospitals to make predictions with cancer and so on, but we should do it in a sensible way, a respectful way.
I understand. Yeah.
And
so we have now. You talked about before this talk about dimensions of data quality. So one would be the errors, and one would then be privacy issues.
Yeah.
So data that, because let's say technically the quality is high, but functionally it should not be released because of privacy issues, right? So are there more dimensions of quality?
Of course, there are even more. You also have, maybe I can give also another example. So you have all these fun sites where they put information about public figures. And from time to time, they also misinterpret information, like they have people with the same name, and they write about someone that is known for being an actor, but they are actually meaning someone else. Or you have mistakes been made. So they can say that someone had an accident or that someone died. And this information spreads around across our social media really, really fast, right? So we have this idea of average people typing information and giving information online. So in this way, they don't need to verify their sources. They are not formal journalists, right? So if they put something in, it spreads across social media and it causes panic and other issues, right? And it's really hard to get it out afterwards. And this is also another aspect. So you have things like accuracy, like consistency. You need to also, sometimes we need to make sure that our data are useful, not just data about everything, but they're useful. When talking about data and data collections, we also need to consider if they have bias inside, right? So if you have data collections about algorithms, you need to make sure that it represents all your population, right? So if you constantly put something about men, then you will retrieve nothing about women at some point, right? Also, time is the other factor, right? So you cannot use information that expired. unless you actually need to put historical information in, right? Completeness also and consistency.
Yeah. And I can imagine, I can imagine two other things which hang together with what you mentioned. I don't know if it's separate, but you can have malicious data, which people made specifically to distort data.
Mm-hmm.
Is that also one of the dimensions, or does it fit on the one of the other ones?
Well, yes, because it would be incorrect data, right? Or inaccurate data.
Yeah, but with a certain goal. It's not incorrect because somebody made a typing mistake or somebody heard something wrong.
Yes, they
didn't check.
Yeah.
But it was deliberate.
Yeah.
And I think there's another one, but maybe we get to that, is because we talk now about data, and you can do lots of things with data, but data is used to train AI. And then AI is used again to generate new data. And then the AI is trained on its own data.
Yeah.
So biases explode.
Mm-hmm. Exactly. And this is where it's currently going, because we are using these huge data collections, and the data that we have now, they are going into the tools that we are using. They are going into the algorithms. They are going into the AI models and this LLM. What does it mean? All these errors are actually causing problems in the end, right? Because if you have underlying errors in your data, you will also have errors coming up when you make queries in your data, right? So this is one important issue to understand when you are using all these tools. We need to understand what data they include, right? And we need to be aware that if these data have errors, we will also see these errors coming up. So this is a really important dimension. And we should also bear in mind that most of these systems are using this closed word assumption, meaning that they only consider the data that they have. So if something is not present there, they cannot give you any answer reflecting it, right? So
I would think, at least I think that would be argued, so that errors in data wouldn't matter that much, because if you have enough data, it can be self-correcting. So if you get a report that somebody is dead, you get also 10 reports that they are alive, so that one report would be ignored by an AI, for instance. Or am I? What do you think about that?
No, we actually do see errors coming up, because all these systems are in the end probabilistic, right? Yes. So they generate facts. They don't retrieve their facts. They are generating their information based on what they have underlying in the data, and they are using probabilities, right? And since they are not using the existing fact, but they are using probabilities, they could actually pop up this incorrect information, right? So it's not really, and they also don't have the ability to understand from their errors, right?
No, of course.
And this is also something that humans would do. If you are given some information that it could be incorrect, or if it could be incomplete, you could actually think, oh, maybe I can ask someone else to give me some information, because I'm not sure 100% that I'm correct. But they would not do this, right?
Well, in statistics, they sometimes do the following. So you do an analysis and some numbers come out of it, and then because there's randomness involved in the process, they do it 10 times and then average over it. So if I 10 times ask if a person is dead, and I get once they are dead, and 9 times they are not dead, and well, they're dead for 10%.
True, but they should also be evolving to this direction. I think they are not yet there. So sometimes we do use also LLMs, and we do get some funny answers, which we see it's obvious there is a mistake there, but they don't automatically correct it, right? They don't see this, which is
but I think, well, you never use. I never use LLMs directly. I always use it through a GPT if I use it. So it has been trained, and then there's a reward network that basically does the selection. So the LLM gives different outputs, and they go to the reward network, and then the reward network picks out the one that gets the highest reward. That's what you get. Of course, then very often that doesn't mean that there is a logical check about it, or a sense check about it, or it is just something that was generated. It's not just the most not the most obviously wrong thing.
Yeah, but we should be aware that it could be that we get some incorrect answers, right? Or incomplete answers.
Yeah, I recently read that it was something like when you just do chatting, then of course it doesn't matter what comes out of it. It's just chatting.
Yeah.
But if you ask for facts, that it's close to 50% wrong what comes out of, let's say, a tool like ChatGPT or other GPTs. I don't know where these numbers come from, but I do know from my own experience that if I know something about the topic, then 50% of the time or more, it's wrong what I see being produced.
Yeah, which doesn't really mean that we shouldn't use these tools. It just means that we should be aware how data quality and what the data they are using and the completeness and the data set and the time set, the time span of the data they are using actually pops up and affects the results that we see. And this is, I think, the important fact here, right?
Yeah, you have to be aware of that because, it's true that when I use a tool like that, it also helps me because if I check it then, this is indeed correct. That means that I was looking in the right, it was looking for me in the right place.
Yeah, exactly. And
okay, so what we discussed before is also a bit there's a lot of evolution also going on in how we use these tools. And there's exploration of there, so we don't know yet exactly for certain tools how we should use them. Or maybe you have an idea, but these ideas are not everybody thinks the same thing. So if we talk about how people use the tools that we have now, the tools that are coming out, based on the perspective of the data is going in it, what should we do here? So if we say, okay, we are a university, we teach students.
Yeah.
What should we teach them? Should we teach them anything about it? So what do you think here?
So at Tilburg, we actually do teach them about it. We do care about the technology, of course, and the innovation that comes out of it. And what we see, at least in our department, is that we have the companies that are asking for it. So the companies ask for students that are aware, they have the knowledge, and they can use these new AI tools, right? So it's not something that we can ignore. The issue is that we need our students not to be just an average user. We need them to use it responsibly. And in order to use it responsibly, they need to have the practical skills to use it, but they also need the knowledge, right? And they need the knowledge on the basic understanding of the information that we gave them from before, right? So we don't stop teaching them the material that we did teach them before. They still need to know how SQL works. What does it mean to have a data system, right? This is basic information. They can still use the AI for it, but they should be able to understand and then judge the outcome that comes, right? So what we are trying to do is have our students to judge and select the correct tool to use for the task that they will be given, for example, at the company. Then they should be able to judge the information that is fed to the LLM, let's say, right? And they should be able to understand that it's their responsibility of whatever comes out, okay? They have the full responsibility of the tool that they are using and the information they get out. And they should be able to use it not just as a users, but where to progress their technology, their information, their tasks, right? So we don't want them to replace the task that they are supposed to do with the new tools. We want them to continue from there. For example, just one example that we tell our students is that when they create an algorithm data model that gives an answer, they can ask the LLM to give them a nice human reflected representation of the answer, right? That would be a nice use for it, right? So not replace the actual algorithm, but help them express in a better way what the algorithm generated in a mathematic form, for example, to the humans that they have in the company. right?
Yeah, but now you talk about responsibility, and you say, and I think that's a very healthy way of looking at it, the students that use the AI are responsible for what they do with the AI.
Yes.
However, I see lots of people discussing that. So who is actually responsible? If there's wrong information coming out of it, is the responsibility maybe for the company that created the AI, or is the responsibility for the company that tells you to use the AI? So
Yes and no. So we prepare our students for different domains. For example, we have students that go in healthcare, right? And there they have a huge responsibility of the tool that they will select. It's up to them to select the tools, right? And it's up to them to make sure that the data is correct and it's complete, and it's the data that it should be for the particular tool. So it's not just the responsibility of the tool. If it's just a black box and they don't have access to the data and they don't have access to information on how the tool is using the data, then maybe this is a selection that they shouldn't do. They should go in another tool.
But that happens with most AI tools. You don't know what it was trained on.
Yes, but we would like to make our students aware of this. This is an issue, right?
Yeah.
And it also, as I said, it depends on the domain they are using it. So it's a different thing to go for a social media company, right, that will predict the next color that will be trendy in the next year. And it's a different thing to work in the hospital and trying to predict which person will develop cancer. So it's two different things.
Yeah.
And this is where responsibility comes in. They should be aware of their data. They should be aware of the tools, right? And they should be able to judge and use the correct one for the situation they have at hand.
Okay, and that's, I think, very healthy. And now if all the students would do this, then I would be very happy. But I've noticed that we bring that up quite a lot, that, for instance, say to students, look, because that's currently the attitude that the university has is, yes, you can use the tool, but you have to be aware what you're using and you have to use it responsibly, and you are still responsible for the output of the tool.
Yeah.
So if you make do an analysis and you say to ChatGPT, do the analysis for me, well, I personally would forbid that bit, but let's say do that, then at least you have to be certain that the analysis was done correctly. Otherwise, you don't know what is there. And then my experience is that you can tell that to students, and they all nod.
Yeah.
And then next, you get an analysis, you look at the analysis and tell the students, please explain this analysis that you just submitted. And then the answer is, yeah, that is what ChatGPT told me.
Yes, yeah.
Okay, how do you get students so far?
Yeah, we're still working on it. So this is where I think this is where the universities and the training comes in, because we need to teach them also what can go wrong, and maybe this is the missing part, right? So we need to teach them what wrong information means, what can go wrong, and how it can escalate.
Yeah.
Right.
Sure. And I can also imagine, look, because I said students,
Yeah.
but of course, there are plenty of students that use these tools responsibly.
Yeah.
They listen to us, they hear this, they do this correctly. The thing is, of course, that at the end, they all get the same diploma. So
Yes.
in some way, we need to weed out the students that don't do it responsibly.
Yes, but in the exams, so we now switched a bit. So we are trying to, when it comes to the grades, we are putting components that are not in which the students are not allowed to be free and use such tools. So we ask them to do exams, or when they have projects, we also invite them and ask them and make sure that they understood what they were doing and it was their work, right? So it's. I think it's more effort on our part as a teacher to do this control. Yeah.
So maybe one question and I think I can predict your answer, but we discussed it a little bit. So you have data is going to be used by certain tools have certain functionalities. And nowadays we see that AI tools like ChatGPT, for instance, are posed as replacing all the other tools. So to what extent would a tool that has all that data in an LLM be able to replace other tools?
No, I don't think that. So LLMs are very generic. They cannot replace all other tools. We have tools that are specialized and do some specific tasks, and they are doing it really accurately. And we have a prediction on how well they do it. That's really also important, right? So as I said, if you're in a hospital and if you're a doctor, you really need to know what accuracy comes out of your system. There's a different accuracy if it's 90% and 98%, right? So these people really need to know what they will expect out of the system, and this is also something important. These generic tools don't offer this functionality for particular domains, right?
No, they don't. I completely agree with that. So I know you're teaching, at least you teach courses in this area, and these courses evolve. So I assume there will be a lot of evolution in the coming years of these courses.
Yeah, so we are actually teaching in the information management degree, and also in the data, we have students from the data science and society. And in this respect, we need to keep up with the technology and the innovation. And it's not, we didn't change the courses just this year because of the LLMs. We keep up. Every year we change like 10-20% of the whole material to reflect the current status. So we need our students to know what is currently available, what is currently going in the trend for the companies, what the companies need, what they want our students to know, right? So almost every year we touch our courses, which is a bit of an effort, but yeah, I think it's worth it.
So often you think, okay, I was teaching a course, next year I have it easy because I already did it once.
And yes, and then you see that in 6 months you still need to update like 10%, which is it is an issue. But I think it's worth the outcome and what we see from the satisfaction of our students and what we have when the companies give us some feedback. I think in general we are good with that. Yeah.
Okay, I think that's a good place to end it. Thank you very much.